Thinking like a Lisp programmer. For an introduction to the wild, woolly world of the pens, which, if you don't understand why I'm saying that, you will very, very soon. Okay, so first, who am I to give this talk about Lisp and thinking like a Lisper and other programming languages? Well, Lisp and I got off to a great start very young. I was a bored teenager with no friends, so what did I do? I read a book called Beautiful Code, which introduced me to Lisp. And from then on, I learned Lisp. Lisp pushed me away for a bit. I learned more Lisp, and I fell in love with Lisp, and here we are. And I've been doing it for a while in a world, in a school that does not seem to promote Lisp. Anyway, so some terms we need to be knowledgeable to understand this. Lisp is a Lisp idea, it's not a language. When I refer to common Lisp, that is a language, that is a standard. And there are different implementations that use it. And there are other Lisps that aren't common Lisp, like Scheme, Clojure, Arc, and maybe Ruby. Some say that Ruby is technically a Lisp, but yeah. Now, a brief history of time. We start the story around 1956, where the state of the art was Fortran. Fortran 1, to be exact. And it's on the punch card, so yeah, this is pretty far back there. It had some characteristics like not being able to do much of anything other than number crunching. And you really programmed the way Fortran told you to program, which was one thing at a time, nothing complex, basic steps. And it was the Fortran automatic coding system, not the Fortran programming language. Because it was designed for just one computer and one computer at all. Something of note, no. Conditional jumps, if statements. If statements all were just go-to statements. If something, go to somewhere else. Now, someone came along to upset this, John McCarthy. Look at that guy. He is the guy that redefined programming for everyone, forever. He published a paper in 1959, Recursive Functions, Symbolic Expressions, Part 1, there was no Part 2. It's actually a very interesting paper. And he introduced, I say invented, conditional statements, basically the if-then-else statement. Recursive functions for computation, garbage collecting, interpreted programming languages, and Lisp 1. And this is a very short paper, too. Great guy. So now we move on. 1960, 1980. Lisp started evolving. Many different implementations just sort of split. None of them were too compatible with each other, which was kind of an issue. So Common Lisp came along, the ANSI community set a standard. They even made Lisp machines for a while, with hardware garbage collection, ran multiple processes, and really pioneered mice, windowing systems, laser printers, and computer graphics renderings. Yeah, great machine. Had actually split the MIT AI lab apart. Okay, now, notice I skipped over the 1980s. I don't like to talk about that in terms of Lisp. Yeah. Yeah, so in the present day, a bunch of open source implementations, Steel Bank, Carnegie Mellon, C-Lisp, Clojure, ECL, commercial implementations, Later Lisp, Lisp works. Yes, people can make money on Lisp. It's true. So now I turn preachy and introduce you to the gospel of Lisp. In other words, what Lisp did for programming. There are some differences between Lisp and set apart from Fortran. All these wonderful, wonderful things. So conditional statements, everyone knows them, everyone uses them now. If then, else, if then, else. How many of you have you ever used an if-else statement? Yeah? Yeah. Thank John McCarthy for that one. And the conditional operator, that is good stuff. I suggest you use a lot of people who disagree. But most of this talk is like this. I would suggest something that a lot of people would disagree, because they teach C++ here. Recursion. Recursion was only a theoretical concept in computer science until McCarthy's paper. People sat around in coffee shops wondering, what if a function called itself? What would happen? You know what? McCarthy said, okay, this is what's going to happen, and we can define our entire language recursively. Because, yeah, it's done. I prefer to write recursion like this, with a conditional operator, because I like a conditional operator, and that's more Lispy. Dynamic typing. We all use Python. You all know that values have types, not variables. Unlike C++, where they say, okay, make this an int, go away, we don't care. Though, incidentally enough, Lisp offers static typing if you want. It's a long, hard process, but it makes your code run, in some cases, just as fast or faster than C, believe it or not. And garbage collection, yay. Stop the world garbage collection. Stop the world garbage collection. You know, your computer just freezes, crashes, cleans up its memory, and turns back on. I don't do that anymore, which is a good thing. Function types. We saw this in the JavaScript talk. Every time they were passing a callback, they were passing a function to a function, which is hacked into C++. You know, function pointers, functors. Lisp does this natively. Lambda functions, that function thing in JavaScript. Yeah. Symbols. Yeah, this is really, they don't have this in C++. If you think of your variable name, you give a variable name the name food. What is food? Most people say it's, I don't know, it's an identifier, it's a thingy. But it's, in Lisp, that is a type, which is important because we can construct functions and lambda functions and all this stuff by passing this stuff. Yeah. And now programs are made of expressions. Nested forms, everything returns a value. Really fun in Lisp only because we use the parentheses. So, example. So in not Lisp, we say, okay, we declare a function. Oh, wow. Okay. I knew I was doing something. Well, you're waiting just as well on what I've told you so far. I realize that in a few minutes your mind is going to be completely blown as the slide comes back up. Actually, it might be a while. The computer has this tendency to hibernate. It takes like a while. Yeah, it's currently still shutting down, so. Yeah, I can't really stop it, because if I stop it mid-hibernation, it's going yeah. Any questions so far?
Get your slides now. Keith, get your slides now.
Huh?
Do you have your slides on Google Docs or something?
No. They use Windows, so they're in PowerPoint. Good, we're off. Now, if this was a Lisp machine, of course, it would have already be running again.
Not much.
Seriously, any questions? No? Currently, we're not in Lisp.
Well, no, like with you.
Well, I developed in Common Lisp, specifically SBCL. I wouldn't tell you how to go out and install it for a computer, but that would be an hour talk in itself. It's actually quite unfortunate it takes so long to install Lisp. Okay, we're back. So we're talking about programs with expressions, right? So when you're not Lisp, you call one thing, you execute a statement, you do if something and statements and all the statements all the way down. It's very linear, right? That's how you're used to thinking when you program. You think linearly. Now if you switch over to Lisp, it's a different way of thinking. Different side of me, different way of thinking. You start with one statement, and then you say, okay, we're going to nest inside of the function definition where we print something to the screen. And inside that, we nest the if statement. And inside the if statement, we nest our conditionals. So that's why I end up with so many parentheses, because everything is nested in itself. And in fact, if you want to execute two statements in a row, you have to wrap that in a special form that lets you execute two things in a row. Now, the biggest thing about Lisp, which is why I have parentheses, is code and data look the same. There's no notion of syntactically special forms like blocks in C++. So if you notice, this is code and this is data. Right? Except for the fact this has a quote in front, they look exactly the same. And this is really the only slide that you need to know for Lisp syntax. We're executing something, we have a function name, and we have its arguments. Which is the first element in the list, then we call it a function, and we execute it. If we put a quote in front, it's not evaluated, and it turns into a list containing the word list, 1, 2, 3, 4, and 5. That's all I need to know about Lisp syntax. And these expressions are called S expressions, or SEXPs. And because of this syntax, we can pass blocks of code into functions, which you can sort of do in Ruby. You can do it definitely in Lisp. Now, the whole language is available to you at all times in Lisp, which is unlike really any other language. When you read in code, when you're parsing the characters of the language, you can set it to do special things and run functions at that time. When you're compiling code, you can do things during compilation and run functions. And when the program's running, you can run code, of course. But you can redefine things and compile during runtime, which is kind of weird. Interpreted code and compiled code running at the same time. That's Lisp. It happens. We're used to it. So this is, anything that can do this is just considered Lisp dialects. So, Oh, by the way, first object-oriented language, it's just a library. It's about 8 pages of a book. You can load it to Lisp and it becomes object-oriented. C++, you had to be a new language. So what? I can see that's the question you're all asking. So here's a task for you. Add an operator to C++. Double star, make it exponentiate numbers. Good luck. You'd probably have to rewrite G++ to do this. In Lisp, it's trivial. You just define it as a function. And it works. You define a function with a name, with arguments, function body. And double star is a valid function name. Literally anything. And I mean it. Literally anything can be a variable name in Lisp.
How about our parentheses?
Yes, you have to escape it, but yes. You can, It really screws up like Emacs when it's looking for parentheses matching, but And so task 2, this is where I do live coding, so it's going to be fun. First time live coding. So you see this Ruby hash table syntax. Lisp only has parentheses, so let's do this. Ready for this? This is going to take 3 hours, and you're ready to record it. Start. I do this in Emacs because if you ask any Lisper what IDE they use, they're going to say Emacs. If you don't agree with that, they'll tell you use Emacs. Is this larger enough? Want larger?
Emacs actually is a Lisp.
Yeah, it's true. Emacs is written in Lisp. When you configure it, you write the code in Lisp. So let's do this. basic introduction to Lisp. So this is called the read, evaluate, print loop, which is where the magic happens. You might know this in Python as the shell, other programming languages, where you can type something like 2. We'll say, okay, 2 evaluates to 2. We're golden. We can do an addition. Notice that plus is just a function, it's not an operator, so we have to put it first. Plus 1, 2, 3. Trust me, when you're trying to do astronomy homework with this and writing out those functions, it gets messy, but Polish notation works well. So basically, our plan for implementing hash table syntax is, first of all, confirmation, this does not work. We do this, it says, it's not really doing anything. It's hung up. It's bored, I guess, for the way you can tell to do something. Doesn't like me, so. Oh, there it is. Okay, error, terminate, thread. Now, what we need to do is, okay, tell the reader, whenever you read in the opening curly brace key, you have to run a function. And how we do that is we use a function called set macro character, which tells the reader, whenever you see this character, that character, we're going to give you a function to run. And just like in JavaScript, it's sort of like a callback function. Sort of not really. It's not really. It's the same type of thing. It's called a lambda expression. And it takes an argument, a string, a character. We say, okay. So what this is doing is it's saying, okay, programmer, you know what you're doing. As Lisp, we know that you know better, and you want to do what you want to do. So here, take the string we're reading in, take the character you're reading in, do whatever you want with it, and when you return, we'll continue doing what we're doing. So what do we want to do? Okay, first thing we want to do is say, okay, Lisp, frankly, I don't care about your character. Ignore it. Just ignore it, declare, you don't care. Right? Easy enough. And then we start doing weird stuff. So in Lisp, when you declare a local variable, you can't just say, okay, I equals this. You have to use a let phrase. So you in mathematics will recognize this. You can say, okay, let x equal 7. Or in this case, we're letting break equal something that we call gensim, which generates a unique symbol, which is useful, I guess. That way, someone can't break your code by passing in some symbol that they're looking for, and then it goes poof, bang. Then we're going to do something really sketchy. So there's this thing in Lisp called the read table, which is the thing that says, okay, there's a character, we read in a character, let's look up and see, do we have to execute a function? And it's stored in the global variable read table. And 2 asterisks say global variable, it's just a convention. And because we're in a let statement here, we do this thing where we copy the read table and we bind it to the variable read table locally, which means that when we run this next function, we use set macro character again, it's going to be using our copy of read table, even though it references the global variable read table, which puts no new spin on global variables. You can redefine them when you run a subfunction. Because we know there's going to be someone out there that wants to use close brace as a variable name. So we have to catch that, and so we have to locally define a read macro, which is most fun. Same thing as usual. Ignore some stuff. I could have just shown you how to do stuff like file I/O and stuff like that, but you can do that in any language. Lisp is really special because you can do stuff like this. So what this just did is it says, okay, anytime you read a closed curly brace, this character would say, whenever you read this, give us the symbol end back. Once we get the symbol end back, we know that we can stop. Basic plan is start at the curly brace, read things until you get to the end curly brace. Then we start processing. We're processing the actual source code of whatever program you're going to run right now. So this is sort of like the preprocessor macros in C++, except it's written in Lisp, and you can do it at runtime. This line I just typed loop for key equals read stream is saying, okay, read the next Lisp token off the stack that you can pass in. And we're going to do it again. This time we're going to read in the value. And we're going to check. Okay, so do. So when not, okay, let me think about this. So the basic thing is we have to check and say, okay, when the key we read in is equal to this end character, we have to stop reading our code and just give us back a value. So when it's not equal, the key is not equal to our end token. That's when, actually we don't even have to do that. This is a while condition. Our loop will stop at this point. And we do this really sketchy thing here where we collect. It says, okay, we're looping through this thing. And we want to push everything you want to do into a list. We want to collect a list, key and value. And bam, golden, done. It's almost all you need to do, except not quite. We'll make a new unique symbol again. And then we create a code template. We're meta-programming, everyone. You can go back, tell your roommate, you did meta-programming today. And they'll be like, what? And you're like, yeah. I wrote code that reads code and writes code.
Why are we checking to see if key equals n and y loop?
Because how are you going to end? You have to check, okay, when you read in a curly brace, and it's the right curly brace.
Yeah, but don't you want it to read in pairs when it does not equal n?
Right. Yeah, just checking. See? You know Lisp.
No, I don't.
But you know enough to correct me. Other characteristic things about Lisp you'd notice is that it uses very descriptive variable names. Like C++, you can get away with using like int I, something like that for a loop. Now, we have to use the words key and value. Now we're going to create a hash table. But we're not really creating a hash table. We're creating a form that evaluates to something that creates a hash table. Yeah, I'm probably not needed live coding for my next presentation. You know the lambda function? And we're going to set in the hash table that we're creating. We're going to push them into the hash table. Just know that these words car and catter, these are just accessing elements of a list. They're sort of, basically they correspond to assembly code mnemonics back when they implemented Lisp originally. So people don't really like it, but they use it anyway. And do this, match all our parentheses, hit enter. It's not complete, okay. We're done. Okay, we have some style warning. That's okay. We don't really care about that. So now, we type this, type that, and it's non-boundary. Okay. Yeah.
Handle the arrow.
Don't worry about the arrow. That takes too long to handle. You can do it. You're not going to do it now. Yeah, this is going badly. CDR, okay, if you remember from project 2 of East 280, car corresponds to first, CDR corresponds to last, so CADR says, okay, take the first element of the rest of the list.
Okay.
Yeah, parentheses are everywhere.
What hash function are you using?
Default hash for Lisp. Notice that we actually have to pass in the function equal to say how we want our hash tables to be equal to each other.
So the reason there's a quote in front of equal is because this function returns code and
No, the reason why there's a quote in front of equal is because we need to make the function, we need to put the function in instead of taking the function out.
If you have working code already, you could just switch to that file.
That's actually a very good idea. Okay, this is Lisp code. It's really long, beautiful. We all love it. And here we go. Put it in, true, switch back to, and let's confirm. That now creates a hash table. So guess what? You know what you just saw done live? You just saw new syntax being added to Lisp. I challenge any one of you to add new syntax to C++, to Python, to JavaScript, to Ruby, to Perl, to any language that's not Lisp. And you know what? You know what we can do? We can say, okay, screw this. We can take this hash table we just made, and we're going to make it so we can index this by using square brackets. And I guarantee that only works because in this other file, I have a function that does that. Right here, bracket access reader. It's the same exact thing, except with brackets. It also works for lists and arrays. Now back to the scheduled presentation. Test 3, implement prologue. I don't think we have enough time for this. Trust me, we can done. Now, what if we have, now the point of what I'm doing is just illustrating things you can do in Lisp that you really can't do. And when I say you can't do, I know all languages are Turing complete and you can do anything in any language, but as I said, add new syntax to C++ without rewriting G++ at runtime. So we're going to do this thing called memoizing, which is caching values in a function. We have this function, slow fun. It's a great function, sleeps for 5 seconds and gives you your argument back. That's really useful for testing the time function. When we say time, pass it 1, elapses, passes time again, and elapses again. So, great. We just create a really slow function that does nothing. So what do we want to do? We can create a function like this. Just know that this too creates a hash table. I really like hash tables. And if our value is in the hash table, we give it back to you. But if it's not, we put it in the hash table and give it back to you. Which lets us do stuff like this. We create a new function. This returns a function. We give it a function, returns a new function that caches the function. And yeah, so we pass in the function, to a function. And this function generates a new function, which you store in this function. And we can call this function a fun call with 1. First time, 5 seconds. Second time, 0 seconds. It just looks it up in the hash table. And you can do this with any function you want. It might be in a library you wrote. It might not be in a library you wrote. You can access the code to do this manually, but no, you don't need to. You can give it a function, and it will create a new function. This is what makes Lisp powerful. Stuff like this. Another thing, enumerated functions. We want to be able to write this. And this is the Lisp way of programming. C++, you say, okay, how does the compiler want me to write a function? It says, okay, give me braces, give me brackets, put a couple of parentheses, variable names, done, we have a function. Lisp says, it asks you, it doesn't tell you. It says, how do you want to be able to write a function? You say, okay, I want to be able to define a function by telling it, okay, if you give me this, return this. If you give me this, return that. Give me this, return that. Give me this, return that. And it says, okay, let's do it. We can write this by hand like this. But what if we want to make lots of these functions? What if we want to make, for some reason, like binary to hexadecimal, binary to octal, binary to sexa, whatever decimal? We can slightly generalize this into a new template. Well, this is, a macro is something that runs at compile time. Something that says, okay, when we're compiling a function, we see this. We want to expand this. We want to say, okay, say name this, and take this template function. Quoted means we're not going to evaluate it. We say, okay, substitute it in, go through this, and we're going to get a new function out. Okay, this works great if you want to write a function named bin to des every time you call this. We can generalize it, make it look like a function, and we can do what we wanted to write is now writable in Lisp code. This is one of the powers of Lisp. You program how you want to program, not how C++ tells you how to program, not how Java tells you how to program, not how the compiler tells you how to program, not how Fortran wants you to program. If you want to Fortran, if you want to program in Fortran, you can do that in Lisp. You can write a Fortran reader that will turn your Fortran into Lisp code and run it. So what's the point? The point is Lisp programming is about how you want to program. Once you program how you think it should be, it transforms itself to do the job you want it to do. So before we wanted to write hash tables like Ruby writes hash tables. We just write code that lets us write hash tables like Ruby writes hash tables. If you want to write Prolog code, you can do that in Lisp. How do you want to solve the problem? Not how does the compiler want you to do this? How does KNR want you to solve this? How does the people at Intel live in Fortran? No. Lisp says, we'll give you minimal syntax to work with. We'll give you just parentheses and a period. And you can do whatever you want with them, program with your language. Incidentally enough, if you want to play a prank on a Lisp programmer, you can write a macro so that when it's in rebind parentheses to something else, which is really nasty because when you try and undo that, you have to use parentheses to call a function. So, yeah, I was trying this out this afternoon and I screwed it up so many times because I would rerun parentheses and I can't undo it. This is the point. In other words, range bound's times rule, any sufficiently complicated C or Fortran program contains ad hoc, informally specified, bug-ridden, slow implementation of half of Common Lisp. H280 Project 2, you were writing Lisp. You were writing Lisp manipulations, that's Lisp. And so enough, there's a corollary of this that says that Common Lisp also falls into this specification, that it contains an implementation of half of Common Lisp. Yeah. You want to compile a Lisp interpreter, you have to have a Lisp interpreter installed first. Because Lisp is written in Lisp. In other words, programming. You're doing it completely wrong. Program how you want to program. Choose your language, or just use one. Tell the language how you want to use me, then use it the way you want to use it. I realize this talk has been kind of preachy, but that's because you're doing it completely wrong. Programming.
Are data structures and common Lisp immutable?
Sort of.
They can if you want.
I don't know. Well, the question is, do you want them to be mutable?
I mean, I guess that's but like, what's the generic code by default?
Generically by default,
Like if you have a list and you, or a list, rather, and you want to like remove an element, do you get a copy of that list with one less element, or have you changed the original?
well, see, there are pairs of functions. Some pairs are destructive and it gives you back a new list that contains sort of like the elements changed around from one of your lists, and the other ones will make a complete copy. So however you want to do it, you can do it.
How is Lisp code maintainable if everyone who sits down does it in that way?
So that's a very interesting issue. Yeah. The easiest way to do this sort of stuff, if you want to redefine your syntax, the best thing to do is make a copy of the read table, which contains where all this stuff is done. Write your code and then copy the read table back. So you have your own block of code where you shadow the read table and you write your code. And frankly, most people just stick with the parentheses because they're beautiful enough for them and they're powerful enough. Yeah.
So can you give us some examples of like practical like projects that you've actually like done included in this? Because it seems like it's pretty like interesting, but like what have you actually done?
Okay. This is actually a big question. What can you do with Common Lisp? So Common Lisp, you can do anything you want. It can bind to C++ libraries, which gives it a lot of power. There's currently multiple websites of mine being hosted on Lisp servers. My newest one, professionalbadass.org. This is running on a Lisp web server hosted on AWS. I have another one that's running on Heroku. You can do it on OpenShift, any platform you want. All you need is a Lisp interpreter. I say interpreter because it's actually a compiler and interpreter. Yeah. Other things you can do, I actually wrote a video game for the first MHAX, won an honorable mention. You can do graphics programming. It's like anything you want to do with Lisp, you can do if you work hard enough. Downsides of Lisp, documentation is hard to come by. Because everyone that programs Lisp assumes that you already know how to program Lisp. And you're smart enough to read the docs or read the source code. Which is why a lot of people don't like Lisp. And because there's people like you that preach at you about how it's better than whatever you're doing. But try it. Try it. You'll fall in love. Once you get it working. Yeah.
Is Haskell a Lisp?
Is Haskell a Lisp? It's Lisp-like. It's sort of. Not really. Not really. Yeah. So, well, here's some questions. If you want to redefine the syntax of Haskell, can you? I didn't think so. Yeah. You can make things into Lisps. Basically, you make Lisp into what you want. Any other questions?